welcome to the first steps video. This whole week is about precipitates, and precipitates are solids that form from solutions. So you can mix two solutions together and it may well turn out that one of the chemicals that is produced doesn't dissolve in water and it appears as a fine solid. So the solution might appear to turn a milky colour or a cloudy colour, or looks like there's little bits in it, and we call those little bits the precipitate. So to give you an example of this situation, let's say I take silver nitrate. Now silver nitrate will dissolve in water, so if I had a test tube of silver nitrate, I'd expect to see in my test tube, silver ions floating around. You have a look at your periodic table, have a look at the left hand side, it'll be Ag plus and NO3 minus ions floating around. So it'll split up in water into Ag plus and NO3 minus, they'll float around and it will look like there's no silver nitrate in the water. It'll just look colourless because it's dissolved in the water. And let's say I mix it with another chemical, which is potassium chloride. So here I'll go. Potassium chloride's got a formula KCl. Go and convince yourself by looking at the periodic table. And then in the potassium chloride, I'm going to see potassium ions. Again, convince yourself it's K plus and Cl minus ions. And they're all floating around. Now let's say I mix them together. So I now mix them together. I'm going to have put it in a beaker. In my beaker over here, I'm going to have these four things floating around. I'm going to have some Ag plus. I'm going to have some K plus. I'm going to have some NO3 minus and some Cl minus. And they're all going to be floating around this beaker. But something interesting happens, and that's silver chloride doesn't dissolve in water. So what happens is these two things join up together. And they stick together and form a solid which we call AgCl. And that is silver chloride. So the Ag and the Cl do not float around anymore. They stick together and they form this solid. And that's the idea of the precipitate. So you'd still have the K plus floating around and the NO3 minus, but the Ag and the Cl form this solid. And that's basically what we're doing this week. This table is your key table to work things out. So it tells you what are soluble and what are insoluble. So it's so that if we put a couple of columns on this side, so I'll write down here soluble and insoluble. We can try different compounds out and see what's going to happen with them by using this table. So for instance, let's say we pick Ki, potassium iodide. We'd look at this table and we'd say potassium compounds are soluble. So that therefore potassium iodide is soluble. If we go further down, we'll also see that iodides are also soluble, but it wouldn't matter because we were told potassium ones are soluble. So we can say that potassium iodide is definitely a soluble compound. So pop potassium iodide up here. Let's pick a different one. Let's go and pick now calcium chloride. And if we go and look at our table here, we'll see that most chlorides are soluble, exception silver, well we don't have silver, mercury 2, we don't have mercury 2 or lead, so we don't have any of those three things, so therefore calcium chloride looks like it's soluble, and therefore we can say calcium chloride is soluble too. Let's go and have a look at lead sulfate now. So write down the formula for lead sulfate. Again, you'll probably need to look at the periodic table to convince yourself that I'm doing this correctly. SO4. And we can see here very clearly it's written down the bottom. Most sulfates are soluble, but lead sulfate is insoluble. So lead sulfate must be an insoluble compound. Okay, let's have a look at silver sulfide. So the formula for silver sulfide is AgS, or Ag2S I should say. Convince yourself of that by looking at the periodic table, and you'll see Ag is Ag plus and sulfur is 2 minus, so I need 2 Ags to balance out the S. And we can start seeing here that this table tells us that sulfides are insoluble except for the alkali metals. Alkali metals are lithium, sodium, potassium and the rest of that group 1 column in the periodic table. And silver is not there. Silver is not an alkali metal. Silver is not the ammonium ion. So therefore this compound must be insoluble. And you basically go all of the way through and determine that. And that's the basic idea of this week. That I can take two solutions, mix them together, and if one of these products is insoluble, then that will appear as a precipitate. If I was writing the first thing as an equation, I'll just create some space for myself at the top. Let me go and move everything up. If I was writing this as an equation, I would write this as AgNO3, which is my first substance, silver nitrate. But the AQ tells me it's dissolved in water, plus the KCl, which is also dissolved in water. When they react together, we produce something that's not dissolved in water, something that's a precipitate, which is my S, which is a precipitate, and then what's left over, which is my potassium nitrate, and that is dissolved in water. So what you can see here basically is that the nitrate and the chloride have changed places. So that I start off with silver nitrate, I end up with silver chloride. I start up with potassium chloride and end up with potassium nitrate. These flip places, and we call this flipping of places, we give this kind of reaction a name, and we call it a double displacement reaction. Which basically means that you've got a couple of ions that flip spots. And that is the topic for this week. Thank you.